Good evening, everybody. Welcome to the presentation of the poster on the PM low-cost sensors in field calibration, influence of sampling coverage and intervals. So as we have seen today, there have been a lot of uses for low-cost multi-sensor devices, as we have seen the examples for teaching in schools and raising awareness. I will try to keep it short because we don't have much time. But what we have done is we have compared the performance of a simple linear calibration models when they operate on differently sampled data from two different low-cost multi-sensor devices. While the more complex calibration models exist, these ones can improve accuracy. We focus here on the univariate linear calibration model. And the two devices that were used are the EcuMesh version 3.5 units and DUNAV-net devices. This experiment was conducted in 2015, and already there have been some research done on the measurements for gases using these type of sensors, but this work is only focused on the PM measurements. What is different about these two devices is that EcuMesh devices measure continuously for 1 minute every 15 minutes, and DUNAV-net devices have a finer temporal resolution, measuring continuously and outputting approximately one sample every minute. And for this experiment that was conducted in the summer and early autumn of 2015, we had minute data from reference measurement stations. So there was a lot of data to compare. And for EcuMesh, we used the measurements from once every 15 minutes from the reference stations, and this is an example of two of the platforms that we measured, the PM10 and PM2.5 measurements, and the linear regression models that was acquired using 1/3 of the obtained data. It was not a lot of data, but the results are okay. And this is the results from the DUNAV-net measurements. We had minute data for this and minute data from the reference source. Also, 1/3 of the data was used for the obtaining of the model. And these are the results for the R-square estimations from the linear regression, using the remaining 2/3 of the data for the quality assessment. And here we can see that the 1 minute resolution of measurements pays out, even though we had much more data to work with. And for maybe future calibration of local sensors, there is a lot of work to calibrate all of the platforms using minute data from the reference stations, but the 15-minute intervals proved to have lower accuracy. Thank you for your attention.
Thanks, Duška. Are there any questions? There are no questions, it seems. So in the you can.
Just one.
Yes.
Now, one point is, from time to time in the graph you've shown, there are some kind of outliers.
Yes.
These are, for me, interesting because they bring information probably to understand if these are a situation of different humidity or whatever. I think if you smooth the main group of
the problem with the outlier, yes, we didn't smooth the data because that is the point that we had a minute data. Usually when they do this kind of calibration, they use hourly data from the reference station. So when you have minute data, you have much more outliers.
Yep.
And so we didn't want to remove them just to check the accuracy even with those. The R-square is much less than if you saw other people that use this kind of, because they use hourly data to compare. So we had much more data even though the interval was short, and we didn't want to remove the outliers just to show all the data that we even though it was a lot of data.
Thank you, Duška. Thank you for questions.